thanks for the introduction. I'm just a software developer. I'm not actually an InfoSec specialist or anything, so this won't be that fancy. What I'm going to talk about is a custom web application I built especially for this purpose, because it might be a bit rude if I just go cracking someone else's application. It's written in Python 3, because why not at this point? It's really good. The structure of the talk is roughly divided into 3 parts. Some general background of the application and excuses for why things are the way they are, of which some of it might be fiction. Then I'll attack it, and then I'll explain what happened and how to avoid some of these problems. Now, I warn you, these aren't new problems, but they are still surprisingly common. And it's just a general sort of example of how things can go wrong. So, an introduction to the application comes first. So, it's a really simple lunch ordering system. It's really simple. In fact, so simple you might say that I've left some features unimplemented. So, it's a bootstrap app, as you can see. It's got a way for kitchens to display their menus. So here I've uploaded the Clinks restaurant menu. You know, it will basically allow you to put up PDFs and serve them from the site. You can see them even when you're logged out. That's no problem. That part of the site's there. And since this site was developed for a company who have expanded, they're actually allowing people to sign up themselves because they can't manage all of the sites themselves. It is hooked into LDAP as well, so they've got LDAP authentication if you've got that. And you can sign up and get an email, but it'll only go to company addresses, so not any random punter can sign up and get in. I've also got a random extra bolt-on to do with phones. It's to help them avoid getting pre-texted, where people ring up and pretend to be someone they're not, so they can check what the phone number is that's called them, whether it's actually from their home office, that type of thing. So if I type in a number here, let's go. It will tell us that, for example, that's from the main office, that phone number. So the admins, they can upload all their menus as PDFs, as you'd expect. But they can also do it as zips and things like that, because sometimes they've just got a whole load of them and they just want to upload them quickly. And, you know, written before HTML5 allow you to drag multiple files in. It's also got a way to clear the Nginx cache, which is a nice technical feature in there, just purely to allow them to wipe that for the PDFs if, you know, they need to, for all sorts of technical reasons. And there's a really basic ordering system where you can sort of set up your fish and chip order or whatever you're going to do and place your order. So, let's discuss some of the features. So, I've mentioned most of these. It's all about just basically allowing people to sort out their lunches quickly and allowing the chefs to do a little bit of admin so that they can advertise what they're actually going to be putting on the menu. The company cares about security. As I mentioned, there's that random feature that got bolted into it to do with the phone number lookup. They've got an OK CSRF implementation. It's a bit custom because apparently they didn't want to use dev-u-random because of blocking or something. They're using an RM to help them avoid SQL injection. They prevented brute force on the authentication URLs. Actually, that's worth a quick demo, because that's quite nice. So it's on all the auth paths. So if I log out and go to, let's say, where's the sign up button? If I just bash on that repeatedly, it should fall over. Well, not fall over. What it does is it slows you down, and then it just returns a 503 that's unavailable if you start hammering any of the auth URLs, so if you try and hammer the login, do any of that sort of stuff. It's also checking that the passwords have got a reasonable strength using some Dropbox provided software that look quite neat. They're hashing their passwords in the same manner. They're rotating session IDs when they log in and out, all the usual sort of stuff. And a lot of this comes for free. You know, Flask has got some nice stuff. It's configured quite nicely out of the box. So we get the no cross-site scripting quite simply. It's just the gingers automatically escaping our stuff. So as I've already mentioned, really, I've hit most of the high points as to what we're using. It shouldn't be a surprise that we're using SQL Alchemy for the ORM, and we're using Flask and Python 3, and all of that stuff's really nice. The basic infrastructure is a little bit weird because it's running in Docker at the moment. So the Nginx and SSH would probably be one machine if it was VMs. But apart from that, that's all fairly expected. You know, we've got an LDAP for authentication, or one of the means of authentication. It's got its own auth database as well, so that you can have just a regular sign-up for the people who aren't on LDAP. And, you know, it's all just linked up as you roughly expect. So now we're going to talk a little more detail about some of the things that perhaps aren't so good. So the session management, we're storing them on the file system, we're just using the Flask session plugin, and that uses Worksol under the hood. And it turns out that that uses Pickle for their file storage, but you know, they figure if you've got to the file system, we're pretty much owned already, so no point worrying about that. They've used random as well. You know, I mentioned they didn't want to use urandom and things, so they've used that in the CSRF, but they've also used it in their sign-up tokens. But, you know, they really don't want people to guess it. So all they've done is they've called it 10 times, joined it all together, and then hashed it. So, should probably solve the problem. I mean, it's worth noting as well that, of course, there are nice big warnings on the Python documentation. Ironically, between Python versions, it changes a bit. I'm not quite so happy with the Python 3 one, or at least 3.5, because it just says, don't use this module, whereas the 2.5 one, it says use system random instead. I think that might be because the secrets module is coming along, but I'm not sure. So their bulk upload thing allows you to upload tables and zip files, and again, the Python documentation has got nice big red warnings on it. But in the zip one, it kind of says, but we should have guarded against this. And it does seem that they have, so, you know, they haven't worried too much about that. So what could go wrong? Well, now for the practical demonstration. So here I have some scripts prepared. So this will start off by trying to get in by attacking the random numbers. And that's actually the slowest part of the attack. I've timed it on general, and it seems to take roughly 15 seconds. And whoops, we've got a shell. Running as the same user as the website. That was a bit quick. So let's go through it a step at a time. So if we start at the beginning and go for the random numbers again,
clear your shell and put yourself at the top would be really helpful for us.
Okay.
If possible, thanks.
So now I'm going to attack it again. The trick here is to actually get hold of existing random numbers. So I've actually made over 600 requests to the website, and then I've asked for a sign-up token. So I've got a reasonable amount of states of previous random numbers. So what I've then done is I've signed up with a random username, so I just generate a random number for my email address. And if I now try and log in with that user, this silly password for my hacked user is just down to the password strength algorithm. So I need one that's at least reasonably long. I mean, it's actually more complex than that, the algorithm, but you see I've got an account on the system. Now you'll notice that I don't actually have an admin menu there. So I now need to get myself an admin user so that I can get to more goodies on the system. So now we move on to the next attack script. So this one has got a few more things, tricks up its sleeve. So the first one I want to do is get an admin, obviously. and it's got the passwords just defaulted in it. You can specify it, but I don't need to because it knows what my hacked users normally have a password set to. So now it's done its thing in the Unix tradition, it says nothing. So now if I refresh on my screen, presto, I've got the admin menu. Now that, as it turns out, was thanks to SQL injection, because the ORM guides you from a lot, but you can still make a platform. So there is actually SQL injection on, ironically enough, the security feature, the phone lookup. So now I've got an admin user. Now we can start to look at the menu uploads, and we can start to make use of those other things that they've ignored, like the tar file extract all method that the warning was against. And also about the fact that we've got session storage, so we're actually going to pop two things at once to get ourselves a nice little shell. So if I just change this to attack, oh yes, of course, one minor detail, I need to be listening for it. And I haven't broken it. Oh, sorry, I'm still forgetting one little step. I need to tell it where to call back to me. And the demo gods are not playing. So, what have I done wrong? Oh, I've crashed it. Oh yeah, there we go. And presto, we've got the terminal. So that's as far as we got with that previous one where we got ending like, I don't know, it felt longer than 15 seconds, but it still wasn't that long. So now we're there, can we do more? Are there any other things that they could have messed up? So take it for granted that the file permissions are reasonably locked down. So there isn't all that much we can write to. We could write to the session directory because obviously the website needs to write to the session directory, which is how we managed to drop the file that we needed to be able to pop the shell. But let's think about other things we could do. So one thing that it turns out to be a good idea to do, despite the fact they've... No, actually, sorry, let's go back. Let's remember that with Pickle, we can run code, and we can run code in the context of the website, so we can use its own code to actually look at things. So let's just have a look at the user database. So let's exit this, restart that. So I've got a few different payloads. So if I change this, so now when we pop back there, that's a bit rubbish. Yeah, it's still a bit rubbish, but there's not much I can do. It's dumped all the, yeah, you can see I've been testing quite a bit, so there's quite a few hacker users there. But there's also the original LDAP users. You can tell then by the fact that they've got stars for their password hashes rather than actual proper hashes. But we could start brute forcing those now if we wanted to run them through a password cracker and pop them. But we should check first, because it's worth just double checking, see if we can actually find our password somewhere on the system. Because who knows, perhaps they stored it on the file system. So let's pop a shell again. So we're here. So now what was my password? So look at that, they've stored them in the sessions. So yeah, now we know where they are. We may as well use its own code against it again and write some code to read the pickles, and we end up with popping, we can see their passwords, and then we get ourselves a shell. Now, in truth, it looks like I don't have a session file that I want. So I'm just going to log back out. Oh dear. CSRF on the logout. What pain. So, actually that's the wrong one. Let's just sign in. Oh yeah, of course it must be when I log out that I actually. So you see here, here's the account I've just logged in with, and that's exposed its password. Again, another nice long one I can never remember, despite the fact it's really simple. So if I also do this, just to sort out the ARP cache, because I want to make use of that. Let's try and jump onto another system. So, we've managed to find a box with SSH, and we've got this password here, and presto, we're on another box. And let's see whether they've got sudo access on that box. Yeah, they do. So now we've got root on another box on the infrastructure, thanks to the joys of single sign-on and people storing passwords in a crazy way. So, let's go back to what just happened. So we exploited the wrong random, we made use of SQL injection, we used malicious tables, we exploited pickle as you'd expect, and then we found that there were plain text passwords lying about the machine, and we jumped onto another machine. So the wrong random, it used to be that nobody really understood the difference. Certainly I didn't until relatively recently. I think probably Dan Boney's Crypto 1 course from Coursera is probably, I think that was probably the tipping point at which a lot more people got it all of a sudden. Because we started to realise what the benefits of the cryptographically secure random number generators were. And thanks to my leak via the cross-site request forgery tokens, I was able to get enough sample data that I was then able to predict what the next random number would be. Because the regular sort of mathematical random, it promises certain things about the distributions, and you can get different random number generators for what type of distribution numbers you want. But they don't promise that if you've seen a whole bunch of numbers, that you can't predict the next one. And so, while you can see it perfectly well, it still won't save you, because it just doesn't promise that somebody who's trying to guess the next number won't be able to. And that's the thing that a cryptographically secure one should do for you. So what I did was, like I say, I pulled in a whole bunch, then it was actually a pretty straightforward transformation. Ask for a sign-up token. I do that really quickly after having gathered the random numbers so that I'm sure that I'll get the sequence right, because otherwise it could be like a couple more if somebody else has made a request in between. And then I just predict the random numbers that it has generated and generate my own token and sign up for an account.
Where was the random number leaked?
So that was in the cross-site request forgery token. So in this case, they've got their own custom implementation. This is probably the weirdest bit of my code, because on the whole I've tried to sort of cut with the grain, as it were, so that there shouldn't be anything that's like obviously weird that I've done, with the exception of this bit, because Flask has already got a perfectly good CSRF token, and I've weakened it specifically so that I can do this. And so one of these numbers here is a timestamp, which helps to deal with expiry, and the other one is a random number, and then it's H-mapped. So as far as I know, it's not exploitable as a CSRF token, so it should work in that context. But as far as leaking the random numbers goes, it's just a convenient source for you. In theory, you can pull it out of other features of a website. And I mean, in theory, you might not be leaking random numbers. And sometimes you'll leak partial bits because you're sort of, only taking so many bits of it. But even then, there are generally ways to figure out a way back to being able to predict the numbers. but I made it really easy for myself because I wanted to be able to do this reasonably quickly. The longest thing to do in this attack is actually just downloading the numbers, just making the gets to the network. It's not actually doing the calculation. So, how do you fix it? With Python 3.6, there's a new secrets library which provides a really convenient API. So the idea is we should be able to just fall into the pit of success. So when all the tutorials are there and all the Stack Overflow questions have been asked newly, hopefully it'll mean that you just Google for how do I generate a sign-up token, and you'll just end up being pointed to the secrets module. And that'll be awesome, because they'll be doing it right, and it will just work. And it will be a bunch simpler than the code that we've all done previously. For existing code, use system random, and for code before 3.6. It hooks into whatever the secure random number generator is on the operating system, and even on modern Linuxes, that's actually been upgraded recently in a sense, in that it's now moved from being def urandom to being a system call, which is actually a little bit better because it means there are another class of attacks that have been removed. And Python will make use of that, I believe, in the more recent versions. The key thing is that you want to be using a cryptographically secure one. And if you're using the operating system one, you generally don't have to worry about seeding because it will manage it, and also the reseeding, which is brilliant. So in code, it's very simple. It's probably a bit small, but literally your actual random calls to say get random bits or whatever it is you're using choice, you just literally stick system random in front of it. That's it, and that will actually effectively make it secure. It doesn't make it any better than it is, because it's still a load of rubbish, but it will actually not be attackable by these means. Or the secrets module at the bottom there, just a single call, way better, and it brings back essentially the same format data, just, you know, a whole bunch less effort. So the SQL injection. SQL Alchemy is really awesome, and when it comes to SQL injection, it seems really awesome. I was very impressed by how long it took me to figure out how to do SQL injection with it. But the thing is that they normally need to allow you to do raw SQL, because they can't anticipate everything that you could possibly want to do. So they provide that facility. And you just need to be aware of those risks and avoid making pratfalls. And when it came to the attack, I made use of the fact that I could execute multiple statements to be really lazy. So with the SQL Alchemy, the way that I did it was using the text thing. That's the way of inserting literal text. So it's a really naive, just, you know, string appending and presto SQL injection problem. So you can see the sort of thing you just stick in there, just break yourself out of the quotes and then put in some extra statements to set your admin users and then commit the transaction, because that way it doesn't matter if your SQL statement causes a crash later on. That's the really lazy way to do it. If I was a proper attacker and wanting to fly under the radar, I'd be cleaner about that, but, you know, I'm lazy. So, fixing it again in SQL Alchemy, really simple. They allow you to do bind parameters on those snippets, as well as the whole query. So, it's a really trivial fix. You just put in your placeholder, give it the bind parameters, and it will do it. And it's really slick and really convenient. So, just be aware that you need to watch out for that when you're doing literal SQL. Then we moved on to the Untrustworthy Tables. So that was when we did the upload. The documentation has warnings on it saying this is not secure. So it's not a particularly hard thing to notice. And since the web server is able to write all of the files that we needed to be able to write, it's a very simple thing. We just created ourselves a new session file and dropped it in. The insecurity is all down to relative paths in this case. So the uploads that we upload were dropped into an uploads folder. The sessions are in a sessions folder, so we just go up one and into sessions, create a file name like that, no problem. And we can predict what the session file name will be based on the algorithm it uses. It just basically hashes it. So I create my sessions basically the same name as the payload on the drop, so I can do whatever. So yeah, just don't use the extract all method, and test whatever code you have written when it comes to these sort of situations. So be careful about symlinks too, because they have the similar sort of potentials for allowing you to break out. I think that's mostly a problem with tarballs, unless you're doing something fancy using a library that allows zip support, but that's not universal, it's not really in the core library. And I mean, it could well be that in your scenario it's perfectly valid to just drop anything weird and just go, sorry, don't want to touch that. I mean, this already checks that the files are PDFs and things like that and says, sorry, I don't know what to do with this file if it encounters it. Pickle, it allows remote code execution. This is definitely not a new problem, and yeah. So being able to write to the file system arbitrarily from a web app generally isn't ideal, but it generally probably doesn't get you remote code execution, hopefully. As long as you've got your permissions reasonably sane, so everything's reasonably locked down, it shouldn't be that bad, but obviously you don't want to allow it if you can.
10 minutes left.
Okay, thanks. So what did we do with the remote code execution? Well, we ran bin.sh, obviously. Then we actually ran the system's own code. What we ran was some standard SQL alchemy stuff using the classes that the app's got defined for the users, and then just composed the user to basically passwords together, and well, hashes together, and extracted them. No problem. So it's really awesome. I mean, what we could do as well is I used some system tools to actually find the other hosts on the machine. What I could have done was write a scanner in Python or find one on the web and use that. Because having Python there means we've got a nice big, very useful tool to get about. So what do you do with Pickle? I personally just don't use it because the risks outweigh the benefits, and there are so many alternatives that it's a perfectly viable option to not use it. If you want to do remote code execution, there are better libraries to do it as well. I believe that DIL was specifically, actually I don't know whether it was created, but it's been developed a lot so that it can push about code for distributed computing, for example. So if you do need to fix existing pickles, and you can't get rid of pickle, there are various methods to allow you to do that. So you can subclass a pickler in Python 3 and add a find class method, and you can say just blow up if you come across it trying to load a class. That would mean that you could only unpickle very simple types, or you could say whitelist the classes that you want to have. You can figure out what works for you, and you can do basically the same thing in Python 2.5 or 2, whatever. And in storing plain text passwords. Yeah. Especially when you're doing it for a single sign-on server. So we've said, oh yes, we don't trust you with storing the passwords, we're going to use LDAP. We'll let you pass them through us, but we're not really going to trust you to hold on to them. And then you hold on to them in plain text. Yeah, that's not good. So, yeah. That's almost never the good answer when it comes to talking to other systems. I mean, it's surprising how often things like that happen, you know, storing passwords in sessions so that you can then connect to another system. I mean, look at what your scenario is. There isn't any one solution to this. I mean, for this sort of thing, it would make sense if the two servers had some degree of authentication. You probably don't really even need to use SSH for this sort of thing, because that's the reason that this has got it, is it's using SSH to SSH and then RM-RF the files that it needs to RM for that cache erasure thing. But the thing is, you just need to come up with a better way than that, really. If you need proper authentication, then perhaps look at an alternative single sign-on thing like OpenID or something, where you have tokens for your service and you can actually do proper authentication that doesn't involve you chucking passwords about the place. So one of the things I wanted to ask you is, if someone reported just one of these vulnerabilities to you, any of these, would you actually consider it to be secure or not? Because I mean, some of them are really obvious. SQL injection, everyone's just no problem. It's, yeah, we'll fix that. It's, A, it's really easy to fix. B, everyone knows about it. And C, it almost always is really, really bad. But some of the others, because say they're deep down in the system and you've got to get to them first, you find that really clever people who actually care about security will still manage to rationalise them away. The code for this website is on my GitHub, so you'll be able to have a look at it if you want to. But just ask yourself that and think, is that the right choice to make? So the thing I really wanted to point out is that it's not a single thing that makes your system secure or not. It's often a whole bunch of little things. You know, one developer decides on a little compromise over here, and another developer over here makes another little compromise, and all of a sudden you've got this whole path through the system to full compromise. And yeah, try and give yourself in the future a chance, and try and be defensive about these things, just like you are with errors, making sure that you check for errors happening. Try to think about security and avoid security issues as much as possible, so when there are warnings, pay attention. Just think about what an attacker might do if they got to a particular point, not just at the front door. Because otherwise what you're doing is you're placing an awful burden on nobody being able to get past the login screen. And certainly in this case, we got past it no problem. So there's a few links here for various things I talked about. I'll put up the slides so you don't have to squint and type it in. There's a PEP for the secrets module and some other bits and pieces. And the link to the site if you want to play with it. I'm not putting up the attack code, but the site's all there. You can see my security blunders too, because I made at least 2 that I know of while writing it, as well as obviously the ones I intended to put in. So, any questions?
Well, thank you very much, Colin. And do we have any questions?
So for the SQL injection, it seems like you would need to know ahead of time where you're using the text part of the ORM, right?
Well, I mean, the text thing is there for you to do complex stuff. Like in this case, what I was doing, so what I was doing was, it's because I've got the actual data on the left-hand side of querying things. I mean, these are all things you're doing while you're coding. So if you need to throw in a text, it's part of the development. It's not something that you just give users an arbitrary chance to insert SQL, because that is the definition of SQL injection. I mean, if that's your fundamental feature that you're allowing people to run arbitrary SQL, then that's a whole different problem to this.
Thanks. I think as a follow-up to that question, what he meant was the user would have no indication of that being in place on the server. Like, would that be something that people would try? I guess it's a common exploit, yeah.
So how would the attacker find that?
Yeah.
The tooling around finding SQL injections is apparently very good. It's sufficiently mature that people have stopped bothering writing how to code your own things to find it, because you just point it at a site and apparently it'll find a large amount of them. Plus, I mean, with open source applications, of course, you just look at the source code. You know what the dangerous structures are. So in the case of SQL alchemy code, I look for all calls to text and then examine whether they are a chance for a SQL injection. But there are tools that will look at your site from the outside and just try bashing in various characters to see whether or not anything happens. In this case, it was really trivial. You just put in a single quote and presto, you got a crash. So you could take a pretty good guess that that might be SQL injection. I mean, sometimes people just with the name O'Callaghan will find them automatically. You know, they're a great type to find SQL injection.
My actual question. Do you find it useful to write stories from the perspective of an attacker? In the past I've been on projects where there was things like, as an attacker, I might try this. Like a user story for an attacker.
I suppose it could be. Especially, yeah, I think that would be a valuable exercise. It's not something I've done, but yes, it would be. I mean, I'm generally in the deep end of the development, so I don't care what the user does to some extent. I'm just caring about the code, and so I tend to more have to convince developers to care about it at times, because a lot of the time they know what they're doing and things, or they're fresh and they just don't know. But occasionally we get someone who say, no, the code's done, that's it. And it's like, oh right, okay, can you give me the URL to your test system and I'll demonstrate it by removing your test data. At that point, that normally solves that problem, but it might not win you any friends.
I was going to re-emphasise what you said about strength and depth, that at each layer you do what you can to prevent someone going through it, because people will go through layers. But if you've got to get through 5 to do the exploit, and each one is trying to stop you, good chances are you just get a bad page here and there and don't lose your sight.
Approximately how many random numbers do you need to crack the, and how?
About 624 for Python, and that's basically defined by its state of the Mersenne twister. Because you basically just need as many as there are numbers for the state, and then you basically do a bitwise transformation that basically gives you the state of the Mersenne twister at that point, and then you can generate the next set of numbers. Different random number generators work differently, but for that one, it's that many.
And would I just search for Mersenne twister?
There are examples of breaking the Mersenne twister, yes. I did actually struggle to find one that would just deal with the Python one out of the box, but there are lots of examples of the Mersenne twister one. It may be that you end up having to implement, basically if you implement the Mersenne twister, then you should be able to figure out how to reverse engineer it.
Cheers.
And I take it you've avoided putting that code on your GitHub, have you?
Hopefully.
Fair enough. Any more questions down there?
Do the numbers, do they have to be in sequence? Basically, there's another user
So,
using the website.
in a sense, yes. I mean, for it to be really easy, yes, definitely. If you account for that sort of thing, you can probably work around such issues, although it will make it harder. So, for example, another way that I made this really easy on myself, I've only got a single process running for the server. So that makes it so simple because there's only one set of state that I've got to worry about for the random number generator. Otherwise, I'd have 5 different ones, and I'd have to make sure that I figured out which ones are from the one, so that I could then get its state and then generate its thing. I'm reasonably sure that it's possible. Well, no, I'm certain it's possible. It's just, it's more effort and more time. And obviously I need to make sure that it runs within the space of a talk.
So you make the parallel between testing and security, and that's very sensible. From a testing point of view, then most of the time, wrong stuff is pretty self-evident. If you've got an integer and you can float it in, it's kind of obvious. And even then, a lot of programmers don't do that. So given what you said, and I completely understand why you don't want to put the source code on GitHub, where should we go to get resources to find the kind of stuff that we need to know what to defend against?
I wish there was a really good answer for that.
I thought you said that.
Because I would have put it on the end slide, but unfortunately I didn't figure out one specifically for Python. I mean, there are lots of books in general about security, and like I was having to flip through the Black Hat Python book yesterday, but that's from the point of view of attacking the system, and not that useful for testing the system for security. It's just lots of disparate resources as far as I can tell. There might be a really good resource, but I don't know about it. If I find out, I'll add it to the end of the slides, but I'm afraid.
Good place to start though?
I mean,
Or is it a case
I
of-
did put one thing on there about, I think it's the avoid dangerous input parsing libraries, that top link, that's one place. And there are also things like, there's like a big naughty list of strings or something like that, which is a whole bunch of inputs that you can sort of put into text boxes and stuff and see whether they break stuff. Because they've got things like SQL injection type vectors, XML breakouts, all sorts of things there that will kind of cause the apps to crash in interesting ways if they're not properly sanitizing or dealing with the output as they should do. So that might be another useful place to have a look at.
Right, thanks.
Okay, let's give one big final thank you to Colin.